everyone, welcome back to This Is Not a Science channel, and today we are back in business. It has been a while and I was a bit busy, so I couldn't upload videos weekly, but now I'm back and I will be uploading science videos weekly, and I hope you guys can like the video and share it to your friends. It really motivates me to keep on working on the channel just to help more people on their science revision. So never mind, let's get into today's topic, covalent bonding. From our previous chemistry videos, we talked about ionic bondings and bonding in general, and now we're going to look specifically at covalent bonding. Covalent bonding is actually quite tricky if you wouldn't know how it actually works. So we started before saying that covalent bonding actually focuses on this section right here, which is the non-metals section of the periodic table. So here are the rules. It's only for non-metals bonding with non-metals, and there will be a shared pair electrons, and the forces are really weak between the molecules. So these are the three rules of covalent bonding. Then we also mentioned an example of Cl2, which is chlorine itself. And Cl2 is actually just two chlorines bonded together by covalent bond because they are two non-metals. So here we have two chlorines. Then we will have to bond these together. And what happens now is, in order to achieve full outer shell, the two chlorines will have to stick exactly right next to each other. This then result in them actually sharing an electron. So now if we can actually count the valence electrons, there are actually 8. So we can count 1, 2, 3, 4, 5, 6, 7, 8. So both chlorines now have a full outer shell. And now you will see chlorine appear in this form as Cl2, which we call it a diatomic molecule. So it always exists in pairs. In natural world, chlorine gas always exists in pairs, just because they have to covalently bond with each other in order to achieve full outer shell. Now let's head on to looking at different examples of covalent bonding, and it could be actually a bit tricky if we don't know the rules. So first of all, I want you guys to familiarize yourself with single bond, double bond, and triple bond. These three are important because there are the three types of covalent bonds that can exist, and their bond strengths are different as well. First of all, we can take a look at an example for single bond molecules. So here we have CH4, which is also known as methane, a type of natural gas. So methane right here, CH4, so there is one carbon and 4 hydrogen bonded together. And most of people will be quite confused, how can you bond so many atoms together? Well, here is how it is. So in order for every atom to achieve full outer shell, we need to have a total of 8 electrons. 8 for carbon and 2 for hydrogen, because remember, the first layer can only have 2 electrons. So what happens now, for this carbon right here, we can see that there are 4 outer electrons and we need 4 more, exactly 4 more to make it 8. And we can look at the hydrogen right here. It is missing 1 electron to get a full outer shell of 2. So what happens is they benefit each other. 4 hydrogen then surrounds the carbon, forming this uniform shape, and eventually they will bond together to form methane right here. So you can actually see the electrons are being shared, and we can take a count right now. Carbon have 1, 2, 3, 4, 5, 6, 7, 8, exactly 8 electrons, and each and every single one of the hydrogen has 2 electrons, 1, 2, 1, 2, 1, 2, and 1, 2. This is a single bond because there's only one shared pair of electrons. Then we can take a look at an example for a double bond. In this case, here we have carbon dioxide. I bet most people would know what carbon dioxide is. It's a very serious greenhouse gas, and it's actually causing global warming, so it's actually not something good for us. And we got carbon dioxide right here, and carbon dioxide is CO2, so we have 1 carbon and 2 oxygen. And the point now is to also achieve full outer shell for both carbon and oxygen, but this one will be slightly trickier. In order to achieve full outer shell, we ended up with a product looking like this, and what we called carbon dioxide. And you can actually take a look, we have the carbon in the center, having its 4 outer electrons actually bonded with the electrons on oxygen. And what happens now is you see this double shared pair electrons. Therefore, that's why we call this a double bond, because there are two shared pair of electrons. Same for here, there are two shared pairs. So they're basically forming two bonds. And what we call these bonds is, we call them bond pairs. These pair right here with the circle, these are the bond pairs, where two different electrons from two different atoms, they actually bond together. We call these the bond pairs. And how about these ones at the outside? Well, we call these the lone pair. The lone pair, they're not bonded with anyone, they're just by themselves, and they exist in pairs. So we will just call these lone pairs, while the bonded ones, we call them bond pairs. Finally, we got an example for a triple bond, and this is nitrogen N2. So N2 basically is two nitrogen bonded together, just like chlorine, but chlorine is a single bond, whereas nitrogen, it's a triple bond. And nitrogen is actually the most common gas in our atmosphere, which takes up around 78%. So it's all around you. And nitrogen has a really interesting bonding shape right here. So let's take a look at how nitrogen bonds. We mentioned before, nitrogen is a triple bond. So let's take a look at how it's going to exist as a molecule. Here we have it. This is the molecule of a nitrogen, and this actually looks a bit odd because you see these electrons squeezed right here in the middle. What it is it's a triple bond. There are three shared pairs of electrons, as you can see here. Here is the bond pair. We have three electrons, three shared pairs of electrons. I'll correct myself right there. It's three shared pairs. That's very important. And on the other hand, we have two lone pairs right here at the side. So this is why we call it triple bond. Just remember, the amount of shared pair electrons determines whether this is a single bond, double bond, or a triple bond. This brings us to an end of the video, and just want to let you guys know that covalent bonding is actually really distinct from ionic bonding, because ionic bonding exists in a really strong lattice structure, whereas covalent bonding is not very strong. The forces between the molecules, which we call intermolecular force, we will introduce in our next video on physical and chemical properties of ionic and covalent bonds. So make sure you like the video, subscribe to my channel, and share it to all your friends who hate science. It really helps me grow the channel. Thanks for all your support. See you next time.